Okay, so solving quadratic trigonometric equation. So what this note is going to be looking at is obviously quadratics with trig functions, but we're also going to look at just a couple of common things that we need to know or need to be able to deduce. First, when we're looking at this, this is a fairly straightforward one. We've got, sorry, I'm gonna just make my writing a little smaller. There we go. So tan is going to be equal to sine x over cos x. And then we're times cos x equals 0. So we're going to cross out both of those. But what we have to recognize here when we're crossing things out off of the bottom, that cos x can't equal 0. Because even though we've gotten rid of it, this is like a discontinuity in a graph. We can't have cos x equals 0. And so that's going to mean that x cannot equal pi by 2 or 3 pi by 2. This goes back to our unit circle where we've got our cos is x and our sine is y. We're just looking at these values here. So if we look at our x's, they're equal to 0 at pi by 2 and 3 pi by 2. So moving through that then, we can have sine x equals 0. That's going to, again, be happening when x is equal to 0, pi, 2 pi. And because there's no restrictions, we would just keep adding a period onto each of those answers and move our way through. All right. So what about a question like this? So first things first, we need to make sure that we're looking within our domain, and that's going to be important. But this question kind of looks like we can use a double angle or a compound angle formula. Really, if we look at it, all we're going to do is factor out a cos x. So we get 1 minus sine x. And then we're going to have cos x equals 0. Or 1 minus sine x equals 0. So sine x equals 1. So the reason that this is kind of like a quadratic, it's like having multiple solutions where we're working down, we're using our zero sum formulas and working through that way. So again, here, we're going to get x is equal to pi by 2, similar to the first question, or 3 pi by 2. And then sine is actually the same. We get x is pi by 2 here. So those are the same solutions, so we would just have to state that those are our answers there. Okay, so when you're doing this, the most important thing, and if you look at this next one, is making sure that we're within the domain that's asked. Now, I would say 90% of questions are going to work just through the domain that is common, 0 to 2 pi. But when we're kind of looking at this, here we've got negative pi to 0. Okay, so that's going to come into play when we're figuring out our answers. So first of all, we've got sine is equal to negative 1 over 2. So we're going to use our cast rule. And we know sine is negative in quadrants 3 and 4. Okay. Sine 1 over 2, our related acute angle, is going to be pi by 6. Okay, that's from our special triangles or from the unit circle, depending on what you want to use. Okay. So right away, if we have pi by 6, and if I look here, there's no k value. So that means our period is going to be equal to 2 pi. But if we're dealing in pi by 6, I'm going to make that actually 12 pi by 6. Because I know, because of this, I'm going to have to change my answer. I'm going to have to make my answer fall within the domain that I want. So first, I'm going to have, I'll work as though we're just dealing between 0 and 2 pi. So we're going to go to quadrant 3. We're going to have x equals pi plus pi by 6, which is 7 pi by 6. Now that's out of the domain. So I would have to take my answer and then say x equals 7 pi by 6 minus 12 pi by 6. Now 7 minus 12 is going to give me negative 5 pi by 6. That's within my domain. That's between negative pi, which would be negative 6 pi over 6, and 0. So that one's okay. And then in quadrant 4, we're going to do the same thing. So we're going to have x equals 2 pi minus pi by 6. We get 11 pi by 6. Then we're going to take it within our domain, and we're going to say 11 pi by 6 minus 12 pi by 6. We're going to get negative 1 pi by 6. And again, that's in our domain. So our two answers are there and there. Therefore, x equals negative 5 pi by 6 or negative pi by 6. Okay, you just got to make sure that you're working within your domain. Okay, when I'm looking at this question, this one looks a lot harder than it is. Okay, now you can do it a couple different ways. We're dealing with our domain here. Again, our domain is negative pi to pi. Okay, so it's not our normal domain. So what we need to consider is kind of what we're solving here. I've got both sine and cos. So I can't solve a question with both sine and cos. I need to create just one, especially when they're quadratics. I need to make them one value. So what I'm going to do is I'm going to change my cos, because it's cos squared. I'm going to use the Pythagorean identity, and I'm going to make this 1 minus sine squared. Okay, so I'm going to have 3 times 1 minus sine squared x plus 2 sine squared x minus 2 equals 0. So then I get 3 minus 3 sine squared x plus 2 sine squared x minus 2 equals 0. I'm going to collect like terms. I'm going to get negative sine squared x plus 1 equals 0. Okay, now there's kind of two ways we can do this. I'm going to do it, I'll show you both methods. So I'm going to then say that sine squared x is equal to 1. I move the sine squared x over to the right, and I'm just going to write sine squared x first rather than 1 equals. Now, when I square root something, I know that I need to include both the positive and negative. So I'm going to plus or minus the square root of 1, which is just equal to plus or minus 1. Now, that means that I'm going to have all of the answers with sign that's 1 or negative 1. So if I have sine, again, going back to the start here, remember, x is equal to cos theta, y is equal to sine theta. Now our 1 and negative 1 are happening at pi by 2 and 3 pi by 2. So we're going to have x equals pi by 2. That's within our domain, so that one's good. And then x equals 3 pi by 2. But if I look at that, that's not within my domain. So then I need to subtract one of my cycles, or one period. In this case, there's no k value again, so one period is going to be 4 pi over 2. So then I'm going to get x equals 3 pi by 2 minus 4 pi by 2, which is going to be equal to negative pi by 2, and that is now within my domain. So here are my two answers. Now, if I were to solve this differently, so let's just do a second method here. This could really be written as 1 minus sine squared x equals 0. And then if I think of it as a quadratic, I could have 1 plus sine x and 1 minus sine x equals 0. This is going to say sine x equals negative 1, sine x equals 1. And that's going to give me the same solutions that we had over here that we'd worked through. We'd worked through our positive 1 over here and our negative 1 over here. Okay? Moving on. Kind of keep going here. Now, you'll notice that like these questions, a lot of them have multiple steps, or you need to rearrange, or you need to solve for something to make sure that we're getting the right answers. Okay, so if I'm looking at this one, first thing I want to do is I'm going to make everything sine and cos. It's just easier to work with. So I get 1 over sine squared minus 2, because that 2 is just there, and I'm going to have cos squared x over sine squared x equals 0. Now I need to state that sine squared x cannot equal 0. So that tells me that x cannot equal 0, pi, and 2 pi. Okay, that's getting rid of my denominator. And then really, I can multiply that sine squared x up to the other side. I'll do it in 2 steps here. I get 1 minus 2 cos squared x over sine squared. That's just collecting like terms. And then I could multiply that sine squared x out, but I've stated my restriction already, so I've taken that into account. So I'm left with 1 minus 2 cos squared x equals 0. Now what that's going to be is cos squared x equals 1/2. I'm going to make then 1 over to the other side, which makes it negative, divided by -2, and I get a half. So what this is going to be would be cos x is equal to plus or minus 1 over root 2. That's taking the square root of both sides. Now what this actually means when we're looking at our cast rule is that we're in all 4 quadrants. We're in quadrant 1, 2, 3, and 4. Because we're taking into account when cos is both positive and negative. Now we're using the whole domain of 0 to 2 pi, which is our regular domain. Now all I need to do is remember my related acute angle. For 1 over root 2 with cos is going to be pi by 4. And then I can kind of just work through all 4 quadrants. Quadrant 1, I'm going to have x equals pi by 4. Quadrant 2, I would have x equals 3 pi by 4. Quadrant 3, x equals 5 pi by 4. And quadrant 4, x equals 7 pi by 4. Again, quadrant 1, it's just the related acute angle. Quadrant 2, it's pi minus that angle. Quadrant 3, it's pi plus that angle. Quadrant 4, it's 2 pi minus that angle. Okay? Last one here. Now, if you get to a question like this and you're stuck with the factoring. Now, the last question, we didn't really have to do any factoring. We kind of canceled some things out. Here, we changed one of our formulas, one of our values from cos to sine, so we could go through and solve it. Here we did a little bit of factoring, and here same thing. This one's a little harder, but if I say like aside or kind of write this somewhere else, that let's say that sine x equals a. So then really I would have 6a squared plus a minus 2 equals 0. Now that's a little easier to factor. Some of you might still struggle with it. You could do decomposition. You could even do quadratic formula if you really want to. But if you factor this out, you're going to get 3a plus 2 and 2a minus 1. 3a times 2a is 6a squared. 2 times -1 is -2. And then I would get 4 minus 3, which would be my 1a in the middle. Okay, now all I'm going to do is I'm going to switch everything back to a sine x. So I get sine x plus 2, and then I get 2 sine x minus 1 equals 0. And now I'm going to work through. Okay, so my first side, I'm going to have 2 sets of answers here. I'm going to have one here and one over here. I have sine x equals -2 over 3. Now, that's not a special triangle, so I'm just going to work through. I'm going to use my cast rule, C-A-S-T. We're negative sign, so we're down here. We're in 3 and 4. I'm going to use my related acute angle. I'm just going to do the sine inverse of 2 over 3. We've already taken the negative into account. I get I get 0.73. And then in quadrant 3, I'm going to do x equals pi plus 0.73, which is about 3.87. And in quadrant 4, we'll have x equals 2 pi minus 0.73, and that's going to be about 5.55. Now I'm going to do the same thing over here, but I'm going to have sine x equals a half. I'll still use my cast rule. We're on quadrants 1 and 2 here because sine is positive. Okay, a related acute angle. This one is a special triangle, so I can use pi by 6. Quadrant 1, we know that pi by 6 is just our angle. And quadrant 2, we know we're just doing pi minus that. So we're going to have 5 pi by 6. Okay, so make sure that when you go through this, you factor it. If you are ever using sine and cos, and your value is greater than 1 that it's equal to after you factor it, you can stop and just say that that's not possible. Because the hypotenuse, the bottom, so if you look at the last example there, 2 over 3 has to be adjacent over hypotenuse. It can't be greater than 1. Okay, so if you get to that, you can just say not applicable or impossible and just stop that side.